Today's lesson we are going to look at chemistry, how to find a molecular formula when you are given the empirical formula and the molar mass of the molecular formula. Let us start. Let's say we are given this information. The molar mass of the compound is 60.10 grams per mole. You should take note that this is the molar mass of the compound, not the empirical formula. It's the molar mass of the molecular formula. Now we are given the composition of each element which that compound is made of. We have 39.97% of carbon, 13.41% of hydrogen, then 46.62% of nitrogen. Now the first thing that we need to do, we need to calculate the empirical formula using this percentage composition. Then from there we find the ratio between the molar mass of the compound or the molecular formula and the molar mass of that empirical formula. So for the first example, we are going to calculate the empirical formula and go straight to today's lesson. The second example, we are just going to take it from the empirical formula part and find the molecular formula. Now the first thing that we need to do, we need to calculate the number of moles for each element. Now we know that 39.97% we convert it to grams by simply putting the grams symbol instead of the percentage. Then we have 46.62 grams of nitrogen. Then from here we can calculate the number of moles so the equation is N is equals to M over M. I'm going to write the equation for just carbon only, and then the mass is 39.97 over the molar mass of carbon is 12. We get that the number of moles is 3.33 mole. Then for hydrogen, we have 13.41 over, we know that the molar mass is 1, so we have 13.41 mole. Then we go to nitrogen, we have 46.62 over the molar mass of nitrogen is 14, so we get that it's 3.33 mole. Then remember, we divide by the smallest number of moles, which is in this case it's 3.33. So we get that nitrogen has 1 mole, and then hydrogen has 4 mole, and then nitrogen will have 1 mole. Then we conclude that our empirical formula is C1H4N1. Now remember the question, we are looking for the molecular formula. So we know that we are looking for the molecular formula. And then what we have, the molar mass of the molecular formula is 60 grams per mole. And then from here, we need to calculate the molar mass, of the empirical formula. Now we know that the molar mass of C1H4N1 will be equals to 1 atom of carbon plus 4 atoms of hydrogen plus 1 atom of nitrogen. From here we know that the molar mass of carbon is 12, of hydrogen is 1, of nitrogen is 14. Then we get that the molar mass of the empirical formula is 30 grams per mole. Now from here we can generate an equation. To find the ratio, we need to divide the molar mass of the compound with the molar mass of the empirical formula. So we are going to say the ratio is equals to the molar mass of the compound, it's 60 grams per mole, divided by the molar mass of the empirical formula is 30 grams per mole. So we can see that this will get rid of this, and then 60.10 divided by 30, we find that the ratio is 2. Now from the empirical formula, we know that this is the empirical formula. We are going to multiply this number of atoms by 2 to find the molecular formula. So C1 multiplied by 2 is C2, 4 multiplied by 2 is 8, 1 multiplied by 2 is 2. So this is the molecular formula. So the idea behind this equation, actually this equation, we need to find this number that we must multiply each and every subscript from the empirical formula. A certain compound has the empirical formula of C5H4, and then that compound has the molecular formula, the molar mass of 128.16 grams per mole. Now we need to determine the molecular formula. Now remember, if we have the empirical formula, we can go ahead and find the molar mass of the empirical formula, which will be 5 plus 4. Then we know that carbon has 12, hydrogen has 1. We get that the empirical formula, the molecular formula, the molar mass of the empirical formula is 64 grams per mole. Then we can go ahead, find the ratio, which will be 128.16 grams per mole, divided by 64 grams per mole. We find that the ratio is 2. So from 65H4 we can multiply by 2 to get C10H8. Another one, you can pause the video and calculate and play the video to verify the answer. Now this is the empirical formula. This is the molar mass of the compound. We need the molecular formula. So the molar mass of the empirical formula, we are going to have 1 atom of nitrogen plus 2 atoms of oxygen. Nitrogen has 14, oxygen has 16. So we have 14 plus 32, and then 14 plus 32 is equals to 46 grams per mole. Then we go ahead and calculate the ratio, which will be 92 grams per mole divided by 46 grams per mole. Then this will get rid of this, and then we need to find the ratio, which is equals to 2. And then we can conclude that our molecular formula is N2O4. We look at the last one. This one we are given the mass percentage, and then we are given the molar mass of the molecule. So we need to calculate the empirical formula first. Remember, you can pause the video and work out this question and play the video to verify. So we know that the number of moles, it will be 7.19 divided by phosphorus has the molar mass of 31. And then let us quickly do the same to bromine. Molar mass is 80. So we can see the smallest is 0.236, so we divide both sides by 0.236. This will, no, actually this one will get rid of this, or it will result into 1. So we know that we have 1 mole. And then this one we get 4.916. And then when we round off to the nearest, we get 5 mole. Then we conclude that the empirical formula is like this. Now, since we have the empirical formula, we actually, before we calculate the ratio, we need the molar mass of the empirical formula. 1 atom of phosphorus plus 5 atoms of bromine. Phosphorus has 31, then bromine has 80. So 1 multiplied by 31 is 31, plus 5 multiplied by 80 is 400. Now 400 plus 31 is 431 grams per mole. Now looking at the question, we are given the molar mass of the compound as 431 grams per mole. So you can see that our ratio will be equals to 1, because the empirical formula is 431 grams per mole divided by the empirical formula of the molar mass is the same. So R will be equals to 1. Now from the empirical formula, 1 multiplied by 1 it will be 1, 1 multiplied by 5 it will be 5. So we can see that the empirical formula is the same as the molecular formula, and that is actually possible. So this is the answer to this question. I hope you got it correct. That's it for this lesson video. This is Wakula SJ. Thank you very much.